Assalamu alaikum. My name is Ali Khan, roll number 21 TE77. Today we discuss the lab number 6 of DSP. So first we go to the lab objective of lab number 6. The lab objective of lab number 6. The objective of this lab is representation of discrete time digital signal into frequency domain where FFT and a resolution of spectrum, computation of magnitude, phase and power spectrum leaking and avoiding spectrum taking. Now we move to the task number 1. Here in task number 1, want to write a MATLAB program to validate the above given decimation program. First divide the given signal into even and odd samples, calculate DFT for even and odd samples separately, and then merge both of them by using formula. This formula. So now we go to the task number 1. So this is the source code of task number 1. So the given signal is x is equal to 1, 2, 3 until 8, and this decimation factor m is equal to 2, and then divide the signal into even and odd samples. X of even is equal to x of 1, m and n, and x of odd is equal to x of 2, m and n. So now we calculate DFT for even and odd samples separately. N even is equal to length of xe and n odd is equal to length of xo. So G even is equal to A50 x of e and G odd is equal to A50 x of o. Now we merge both of them by using formula. So n is equal to length of x and x is equal to zeros, which is from 1 to n. Now we using for loop and using this formula. In the last we display the result. So display original signals and display decimated signal and display reconstructed signal. So in the output we can see this is the original signal, which is 1, 2, 3, 4 until 8, and this is the decimated signal. This is the decimated signal, which is decimate by 2, and this is the reconstructed signal. Now we move to the task number 2 and lab manual. Here in task 2 says that check the above program for signal given below. So here x1 from x1 to x8, which has some different values, and the last one in the last says observe and find any symmetry and frequency representation, and also match the calculated DFT with standard function of MATLAB. So we go to the source code of lab number task number 2. So here is the source code. As you can see, the given signal is x1 is equal to 2, 4 and 2, 4, and the decimation factor is m is equal to 2, and divide the signal into even and odd samples. X of e is equal to x of 1 into 1 to 2, and x of o is equal to x of 1 into 2 to 2. So Then calculate DFT for even in odd sample separately. N even is equal to length of x of e and n of odd is equal to length of x of o, and g of even is equal to f of t into x of e into n g of odd is equal to f of t and x of o. Now we merge both of them by using formula. So n is equal to length to x of 1 and x is equal to zeros, which is from 1 to n. Now we using for loop and use this formula. In the last we display the result. So display the original signals and display decimated signals. Now we compare the DFT with standard matlab function. Display DFT of x1, display FFT of x1, display FFT DFT of decimated of x1 and display of x. So in the output, this is the original signal, which is 2 4 and 2 4, and this is the decimated signal, and this is the DFT of x1, and this is the DFT of decimated of x1. Now we move to the task number 3 and lab manual. In task 3, and task 3 says check the program in task 1 for the signal given below and compare it with standard function. The signal is given. Now we go to the task to the source code of task number 3. So here in the source code of task number 3, here is the given signal x and y, which is given in the lab manual. So then the decimation factor, which is m is equal to 2, and then divide the signal into even in odd samples, which is this, and calculate DFT for even in odd sample separately, which was in previous. Then calculate use for loop and use formula, and then display the original signal and decimated signals. Then display original signal of x and display of x, display decimated signal of x and display inverse FFT of x, and display original signal of y and display of y. Then display decimated signal of x and display inverse FFT of y. Then compare DFT with standard matrix function. Display DFT of x, display FFT of x, display DFT of decimated of x, display of x, display DFT of y, display FFT of y, display DFT of decimated y, and display of y. So here in the output, this is the decimated original signal, which was in the lab manual and in the source code. This is the decimated signal of x, and this is the DFT of, and this is the original signal of y, and this is the decimated signal of x, and this is the DFT of x, and this is the DFT of x. DFT of a decimated signal of decimated of x, and this is the DFT of y and DFT of decimated of y. Now we go to the task number 4. So first we go to the lab manual. Here in task 4 says we can further subdivide the above decimation of to two samples and calculate DFT of two samples, then two samples DFT added to form four sample DFT and two four sample DFT form eight samples DFT and so on. This two-point decimation is called reduced to fast Fourier transform algorithm and write a program my DFT and my FFT that transform a given signal into its frequency representation using reduced to FFT algorithm. Now we move to the source code of the task number 4. So here is the source code. Here in source code, first we define function x, which is x is equal to my FFT and n is equal to length. For base case, we use for loop n is equal to n and x is equal to x. So then we divide the signal into even in odd samples, which is like previous, and then we merge the DFT x is equal to zeros, which is from 1 to n, and for k is equal to for k is equal to 1 to n divided by 2, and then use formula, and this is the input signal, which is x is equal to this, and calculate frequency representation using my FFT function, which is x is equal to my FFT of x, and then compare with the standard matlab function x matlab is equal to FFT of x, and then display the results. Display my FFT, display of x, display matlab FFT, and the last the output like this. So this is all about the task number 4. Now we move to the task number 5 to the lab manual. In task 5 says calculate the first Fourier transform using your own function, and task 4 and compare it with the standard function of calculating DFT for the following signal. Here is the 4 signal, which is W, X, Y, and Z. So now we move to the task source code of task number 5. So this is the source code. Here in source code, first we define sample which was in the lab manual, and then calculate the FFT using the custom function, which is this, and then calculate the FFT using the standard function, and which is this, and then compare the result, and then display result of my FFT compare with FFT, and then display signal of Y, and then display custom of function, and then display standard function, and display a signal of z, and display custom function, and display standard function. In the last, the output result of my FFT compare with FFT, signal of y, custom, this is the custom function, and this is the standard function of for y, and this is for signal z, this is custom signal is, and this is standard signal. So this is all about the lab number 6 of DSP. Thanks for watching.